Linear variable differential transformer, that is, LVDT, is a common type of electromechanical transducer or sensor, which is used to convert the linear motion of an object to which it is attached into a proportional electrical signal. LVDT offers good accuracy, high resolution, good sensitivity, and relatively zero mechanical friction, which makes preferable sensors for measuring the linear displacement. This is the basic construction of LVDT. A typical LVDT consists of a cylindrical transformer that carries 3 coils. One primary coil at the center of the transformer, and on either side of the primary coil there are 2 secondary coils. The secondary windings have an equal number of turns and are identically placed on either side of the primary winding. The primary winding is connected to an alternating current source. A movable soft iron core slides within the hollow space of the cylindrical transformer and therefore affects the magnetic coupling between the primary and secondary coil. The displacement to be measured is applied to the arm attached to the soft iron core. Working principle of LVDT. When the primary coil is given in AC alternating current, supply current flows through the primary coil and it further induces the current in the secondary coil according to Faraday's law of induction. Thus, EMF generated in one of the secondary coils be E1, and the EMF generated in other secondary coil be E2. Thus the net EMF will be equal to E1 E2. Since the coils are bound opposite to each other. This is the basic working principle of LVDT. Working of LVDT. Based on the position of the soft iron core, there could be 3 cases. Case 1. When the core is at the center. When the core is at the center, equal voltage is induced in both the secondary coils, that is, EMF E1 in the secondary coil S1, and EMF E2 in other secondary coil S2. Since the 2 coils are equal in turns and but of opposite magnitude, therefore, this EMF generated will cancel each other and the net EMF generated will be null. That is, output EMF E equal to E1 E2 equals 0. Therefore, this position of the core is also sometimes called a null position. Case 2. When the core is at left-hand side. Since the iron core is closer to the secondary coil S1, more flux links with the secondary coil S1. Thus, output EMF of the secondary coil S1 would be greater than the EMF generated in the secondary coil S2. Therefore, the net output voltage from the secondary coil will be positive. That is, output EMF will be equal to S1 S2 equals positive. Case 3. When the core is on the right-hand side. When the iron core is on the right-hand side from its null position, the flux linking the coil S2 of the secondary coil is more as compared to the flux linking the S1 coil. Therefore, greater EMF is generated in coil S2. Thus, EMF in coil S2, that is, E2, will be greater than the EMF induced in coil S1, that is E1, and hence the net output voltage will be negative. Thus, we can conclude that the amount of EMF induced in the pair of the secondary winding is proportional to the displacement of the movable iron core. This output voltage can be measured to determine the relative position or displacement of the iron core. The output voltage is a linear function of the core displacement. Advantages of LVDT. It has got low hysteresis. Thus, has got good repeatability. Low power consumption. With high output and high sensitivity, the output of the LVDT does not require any further amplification. Rugged in construction. No frictional losses, thus accuracy of the LVDT is high. Disadvantages of LVDT. LVDTs are sensitive to stray magnetic field, hence need to be protected from stray magnetic fields during their operation. LVDT performance is affected by variation. Large displacement is required for producing appreciable differential output. It is affected by the temperature and vibrations. Applications of LVDT. LVDT can be used as a secondary transducer or sensor for measuring force, weight, pressure, etc. Brain probing in medical applications. To provide displacement feedback for hydraulic systems. To measure the distance between the approaching metals during friction welding. Thank you.